In today's podcast of Data for All, Data Science 101. Welcome to the Data for All podcast. I'm Charlie Apigian.
And I'm Charlie Yielding, where we want to empower you to think different with data.
In today's podcast, we felt it was time to go through and explain the basics of data science.
Yeah, and I know we've talked about it in bits and pieces, but today I want to take the opportunity to lay out the important aspects of data science, starting with why should we even talk about data science?
Okay, so why do we talk about data science? So data science is this thing, we've been hearing about it. It's 10, 20 years ago, they came out and said that data scientist was the hottest new job out there, and we keep hearing about it. And so why? Well, first of all, there's a lot of data now out there, right? Mm-hmm. And that data is being used by people to hopefully make better decisions, use it to be able to project things, predict things. Mm-hmm. It's doing a lot of stuff. We're hearing about it all the time, artificial intelligence, everything. The crux of that, the person that is at the center of that is the data scientist.
Mm-hmm. And as of right now, in 2023, there are more data scientist positions open than there are data scientists, correct?
I'm going to rephrase that a little bit.
Okay.
There are not as many data scientist jobs as you would think out there.
Okay.
But there are a ton of jobs at a very high level, high as in, a need for it, mm-hmm. pays well, that needs data science skills.
Okay.
So people still aren't sure what to do with the data scientist, but they want data science.
Yeah.
If that makes sense.
No, it does. That's something that I've seen in the industry that I work in, mm-hmm. is that we've got a large focus on AI, machine learning, and have had that same focus. But then there's the idea that, like, I have all this data that I could be using, and mm-hmm. I want somebody to mess with it. And that's a data analytics person, right? And it's like, no, the data analytics person reviews the data. The data scientist does so much more than that. And you think you want somebody that's not a full-blown data scientist, but you really do need somebody that can do the data science things.
Yeah. And I think since we're talking about the why, I think we need to just not define it with a definition. You can go Google definition. I'll actually mm-hmm. tell you what it really, if you want the definition. Mm-hmm. But what I think is confusing is what are the different aspects of data and then the jobs that are out there for data. Mm-hmm. So, first of all, if you're entry level, in almost every case, the most common job that you can get is probably a data analyst. Mm-hmm. And that is going to be somebody that manipulates data a little bit maybe, mm-hmm. And creates reports, charts, things like that, but basically helps you at the basic level.
Yeah, and so a lot of that's data visualization mm-hmm. and communicating certain contractual SLAs through data. Yeah. They're not necessarily out there like finding new ways to generate data, but they're definitely working with what they have to help build a better picture of what actually is going on, right?
Yeah, absolutely. And if you were to say, then if you stay that's usually a business-related job. Yeah. And so a lot of times you'll hear in colleges of business, they'll have analytics, mm-hmm. Information systems and analytics, business systems analytics. That usually is a role where you get the basics of the business topics. You get mm-hmm. accounting, you get your marketing, you get your management, finance, and then you get analytics courses, a little bit of programming, but you're not a full-blown computer scientist, and mathematician. You understand data. You mm-hmm. can pull data. A lot of times they're also probably, good at database. Mm-hmm. And so those might be some of the precursors, but normally not a data scientist.
Okay.
At that point. The other part that I kind of just hinted at is database itself. So you have data analyst that does kind of that rudimentary type stuff. Okay. But then there's the database administrator or the person that works in the database field, which basically means there is a huge need to mm-hmm. retrieve data and also to create structure around where our data lives. And that's a field.
Yeah. And so to use an example for that, so it doesn't matter what kind of value or how your data, like how much data you have, if it's not organized well, right. it's not going to work for you. And what I mean by that is like searching, like the industry I work in, the biggest problem they have is like their data is not consistent. Meaning, if you have this data point, it doesn't always show up in column X, all the way down. They'll have some in column X, they'll have some in column Y, but also in column Y is a little bit of this data, and you can't really parse it out without setting up the structure. So is that what a database manager would do?
Yeah, and there's a little bit of data architect might be another term if you get into that, and that's usually the ability to design the entire structure. But really, we're just talking about database admins.
Okay, so the data cathedral people, those are the architects.
Yes, they're the architects that make the data warehouse, the data lakes, the data blah, 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 and you name it. So there's that end. Now, when you start blurring into more of the data science world, yes, now you're starting to get into those roles. And when we say data scientist, and then we're gonna talk about another category as well. So we've talked about kind of the rudimentary, entry level data analyst, the people that retrieve the data, the database admin, the people that play with the data, the ones that will use algorithms and the math and the statistics behind things to be able to predict or to be able to tell other stories with data. That's the role of the data scientist.
Okay.
And when we say that, that is going to include a little bit of programming, a little bit of math and statistics, and most important, which is hard to get in education, but hopefully you get it in your job, is business acumen or understanding the business that you're actually working the data with.
Yeah, I can appreciate that a lot because that's the approach that I took. Like I was taking data, initially I was taking data to say, what does it mean to do a good job? And how do I create lead metrics around it? And lead metrics are essentially, indicators of performance. And think of it like a fence. Like it's a fence around your job. And as long as your lead metrics are good, then you're doing your job well, and you get freedom within those lead metrics. So how you specifically do your job, we don't micromanage as long as you're hitting your big numbers. And then that transitioned for me personally into, okay, so how do I predict the future with the data that we have? How do I tell better stories with the data we have? And that's one of the things that we've always leaned on. And I feel like we're in a really good position because our knowledge base is clean, our databases are clean, and everything that we need from them, we throw it into Power BI because that's the most most useful tool for us, and it has a lot of power to it. And so we get BI dashboards, which is BI stands for business intelligence, which is where we're going with this.
Yeah, and so what is, let's make the distinction between data science and business intelligence. So a lot of times when we say business intelligence, that is more of a visual look at your data, isn't it? Where data science now is we're looking at your data, but what we're actually doing is we're probably training an algorithm to be able to give us some type of answer.
Some sort of insight or an answer that we know the answer to already, or an answer that we've asked the question for specifically?
It could be any of those because there's different categories within data science. Data science is not a specific, it only does this. And so we're going to obviously get into a lot of the different components of data science. Now, the other, before we go into, because I'm about ready, I'd love to go right into what is data. What is data science?
I'm gonna keep you from it.
Yeah, but the other component. So we've talked about again the entry level job, the people that retrieve the data, database admins, the data scientists. We're sticking to the role of manipulating data to create predictions and using algorithms, things like that. That's the data scientist, and then the other part goes kind of like to the post part of creating a model. So again, a data scientist, if you were to say, what do you create? They would probably say they create models, predictive models in most cases. When you take that model and put it into the everyday use within a business, now you're probably a data engineer is what that's called. So that would be the other role that you hear a lot about. And so think about this. You create an algorithm, you're an insurance company, and you want people to go on a website and type in a couple of things about themselves, and they automatically get a rate. Well, that is an algorithm behind the scenes that was probably created by a data scientist or somebody like that.
Yeah.
And they want, or let's say they did do that at least. Well, now that data scientist does not know how to get that where they take text boxes from a website, brings it into a model, and then gives you an answer of, $150 a month. Need somebody else usually to do that understands the infrastructure and how to get something into production. So that would be that last job, the data engineer.
Okay. So that's a good field of data people. And so today we're going to hyper focus on data science.
That's right.
Maybe a little bit of the others, kind of like to contrast and whatnot. But this is going to be a meaty episode in that it's an empowerment episode that's intended to empower people to make decisions, to understand the world that they live in better. And so who exactly is this episode for, though?
Yeah.
And that's a trick question.
Well, because we know it's in the title of this podcast. But I think we can get a little bit specific. I think what we definitely don't want to get to today is, going down the rabbit hole of regularized regression and lasso versus ridge and, getting into the weeds on that.
Yeah.
That doesn't make sense for our audience because what we care about is we know there's a lot of people out there that do know a little bit about data science or maybe nothing, and they want to feel like they understand it enough to either go and become a data scientist if that's what they really want to do, or just be in the room with the data scientist and feel comfortable.
Right. So that's exactly what I was getting at. So if you're late high school, in college, in your 20s, like this is what it means to be a data scientist. And so if you choose, and you can be any age, but if you choose to go down the career path, this is going to have a lot of what you're going to have to learn.
Right.
If you are a business person, you're going to be in the room more and more with a data scientist. You're going to have to articulate your ideas to somebody that's going to try and then turn those into a model, like what you talked about. And so the understanding of what and how they go about things will allow you to speak more clearly and efficiently with them in those meetings, and so you're going to waste less time. But for the general person out there too, who has no intention of becoming a data scientist or working with data scientists, you're going to hear data science forever and ever and ever. And so take this hour and use it to put it, to file away like what a data scientist is. So when you hear that term in the future, you know what their swim lanes are.
I love that. And remember, we want everybody to be at least data literate.
Yeah. This is a part of data literacy.
And you got to know data science. You got to appreciate data science. And I think when I say appreciate, that means you don't have to know everything that's in there. But when somebody says there's a relationship between these two variables, you should know that there was probably a regression analysis done there. And you don't even have to know the word regression. You just have to know that when one goes up, the other one goes up or down. And if you can understand that's the power of data a lot of times. And, you can let the data scientist, but again, you're going to be in the room, not with a data scientist right now. You're going to be in a room with somebody that has data science skills. And so it may not be. It could literally be a colleague that just got good at it. We're seeing that a lot.
That's where most of my experiences with colleagues that got good at it. Yeah,
and what we're seeing a lot, and I'm saying we as in I myself and Jason King, who's at Exelis, who's definitely a data scientist. Actually, he just won Data Scientist of the Year here in the Nashville area.
Shout out to Jason King.
And he's been one of the organizers for the data science meetup, the Nashville one, for years.
So you guys just recently invited me to the first one that I've been invited to. Right. And what do you call it though? It's the best name.
So we do meetups, and every quarter we do an anti-social.
Oh, okay. The anti-social meetup.
That's right, because we are data science people, therefore we are anti-social, supposedly. And it's a play, of course, on that. So,
no, I like it. It's a good name.
And at that last antisocial, which we just had, we notice a lot of people have trained to become a data scientist, but most of them don't have a data science role yet. And it's not that they're doing some data science, but they're not every day just building models for a living.
Okay.
But they are using data that turns into action. They are looking at things, in certain areas. So the true data scientist isn't there yet, but it's getting there.
So you're saying they're more data generalists? Because I would fit into that category where I can play with data, but I'm not building models. Well, I maybe not that far down the road, but that's kind of where everybody is that didn't go through the data science curriculum at your local college, because that surely exists, right? Like I can go to school right now at any college and get the same education to be a data scientist. The
exact same education. Now, of course, it's still varying. We're still in the early stages. We definitely want to talk about that. But think of it as your normal bell curve. You have people that all they're doing is building models to help save lives. I'm not saying everybody's doing that though.
Yeah.
Then there's this big group in the middle that gets to do some, but it's not just their only job. And then there's some that are really trained up and then they're not doing it at all. So, and hopefully that's a smaller number. So there's this big group in the middle that if you ask most of them, they would pivot into a different job because they want to be that data scientist. But you know what? It's okay if our idea of data scientist never actually exists.
Really?
Why not, instead of being a person that all they do is sit around all day and build models, you're instead somebody that adds value to a company, that is in conversations, that leads to strategic actions for your organization.
Yeah.
And you help empower those conversations. That's more than just a person that sits in a room and builds models all day.
Well, that sounds like that takes a certain amount of business acumen too, though.
And I think that is important for a data scientist to have. It's not easy, but I remember, a data scientist to me is not a mathematician.
Sure.
Now, a mathematician, maybe you're not leaning more towards that. You have to be somebody that has this intersection between programming skills, so computer science, mathematical and statistical skills, and business acumen. You have to have all three. You don't have to be amazing at all three. You probably can be good at two of those and appreciate the other, and then you have different skills, because within the data science world, there's different roles in there as well.
Sounds confusing.
It is, and that's why we're having this conversation today.
Good. Well, let's just jump into it then. We've hit on data science and some of the surrounding professions and whatnot, but let's just go ahead and dive into the meat of the episode. And
okay.
So tell me, Charlie Apigian, data scientist, what is data science? Well,
should I read literally like a definition of it? Because one of the things when I go too abstract, I think sometimes it's hard, but I'm going to stick to the definition here.
Okay.
Data science is first and foremost a multidisciplinary field. Okay. What does that involve? It involves extracting meaningful insights and knowledge from data. Okay. So that makes sense to us.
Okay.
Using various techniques, algorithms, and tools.
Okay. And that's kind of the stuff we have not talked about yet.
That's right. We have not talked a lot about what are those different techniques specific to the data science world.
Yeah.
It does combine, and so I'm going by definition here because it's going to sound like what I've already said. Mathematics, statistics, computer science, and domain expertise to analyze. And I think this is important. This is the difference between statistics and data science.
Okay.
Large volumes of data.
Okay.
So in the past, we had small data sets that we used to generalize for the population.
Yep.
That technically is statistics. And so data science, we have a ton of data, and we're trying to uncover patterns, trends, correlations, and anything else that can help us with decision-making and problem solving.
So if I've heard the term big data before, and I work for a big company, like say there's 100,000 employees, the company generates very large amounts of data, so big data. And if I'm a spreadsheet hero, which that's where I lie, I would have a really difficult time dealing with that amount of data. So is that where the data scientist steps in? Is like, I got this, get out of the way.
Yeah, I mean, if you can do Excel, Microsoft Excel, you're usually on the analyst side of things. You can only get a certain number of rows and columns. If you get a 4 gig file, it's going to be slow.
Yeah.
But in the data science world, that would be considered small. So, and what happens between data science and statistics, just to talk about this real quick, and then we'll get into more of what is data, because I don't think we can talk about data science without talking about what is the data we're talking about.
Yep.
Statistics is a lot of times you're looking for whether it is significant or not significant. You remember if everybody took statistics back in the day, you did hypothesis testing. Well, in the data science world, because data is so large, everything's significant.
Is it?
Yeah, pretty much. And so it's really hard to find things that are spurious when there's always going to be these little connections.
Wait. It's really hard to find things that are what?
Spurious.
So please tell me what that means.
Well, spurious correlation means that it's not a real correlation. It's just randomness.
So it looks like it could be significant, but it's actually not.
Yeah, if you have ice cream, that means there's more Catholics in a county or something like that, and you can find that, but that's not a correlation.
Like why crime goes up in the summertime.
That's right.
Why crime goes up when ice cream sales go up.
That's what it is, and technically, it's not the ice cream that did it. So it's a spurious finding. So anyways, yes. So there's a new term for you, Charlie, today. But let's go back to our term for data.
Yeah.
And I'm going to read the real definition, and then I've got my own very easy to understand and encapsulate as well, which is my own little definition. But if you read, and I'm going based on literally just the old ChatGPT version. Data refers to a collection of facts, statistics, or information that can be processed, analyzed, and interpreted to derive meaning and knowledge.
So a lot of numbers?
That's what it sounds like, right? I will say this. The definition does continue, and I'm glad it does because it says it can take various forms, including numbers, text, images, audio, video, and more. And I think it's very important today to say that data is so much more than just numbers. In the data science world, we normally think about numbers in columns and rows, and we literally have names for that. But when we now hear about ChatGPT or large language models, that's not numbers. That's text. That is large volumes of text that is more of a natural language processing technique than it is. And we're going to get into what that is and how that works in the whole data science world. I love my simple definition. It's just data is a capturing of an imperfect view of reality. In other words, whatever has been captured about reality, to me, is data. So that includes all the text, all the images, all the audio, all the video, all the numbers, and anything else that was captured that you have either stored or processed and hopefully used to make better decisions and problem solving.
So since we first said that, or since you first shared that definition of data in the first podcast, like GPT has come out. And so one of the things that ChatGPT is known for is being confidently incorrect. And that's because there's data out there. And as a data scientist, I assume this is something you have to deal with that's just not correct. Like you're dealing with imperfect, like literally imperfect data because it was captured incorrectly and whatnot. But that could throw off your measurements of the entire situation.
That's right.
So you have to define or not define, you have to determine through, I assume different processes you have what's good data and what's not.
Yes, and I think that is so important that OpenAI does include that in their description or their warning, basically. OpenAI, again, is the ones that came out with GPT-4 and ChatGPT, and recently came out with an iOS app version of ChatGPT, and it works just fine. Actually, it works quite well. But in thinking about that, what normally happens in the statistics world, you say, well, of course, data is not perfect, but the more we get, the more confident we are. We like to call it the central limit theorem, which basically just means the more data that you have, the more you feel like it represents the population.
Okay, the closer to perfect data you can get.
Right, and so the problem when we say imperfect is for two reasons.
Okay,
first of all, you may not have enough.
Yeah.
And second, the stuff you have may not be correct.
Okay. So we talked about the incorrect part, but then a whole nother part of it is like we don't have the the variable to this equation to answer what we want to know.
I'll give you a great example. I like to use height as an example because I am kind of challenged in the height category.
Gravity keeps you down.
Gravity keeps me down, but keeps me grounded.
Okay.
See, there you go. So yeah, I'm a whopping 5'7". And so if we were trying to find out the average height of a person in the United States and only went to my church, which is a bunch of Armenians, where the average height might be 5'3".
Oh, really?
Well, when you add females and males.
Oh, okay, sure. Okay.
Then we are skewed one way. So people that go, Armenians are not the perfect representation of the entire population in terms of height. Or what if I went to a basketball camp of prospective NBA talent, and all of a sudden we're at 6'5" as the average height? That's not a good representation of the population.
Okay.
But if I then took that plus the Armenian church plus the local place, the more I get, the more random I get,
right,
the better I have of representing the population.
So if the question was, what's the average height at an Armenian gathering?
That's different. That's a different population.
Then you would have what you needed. But when you're trying to answer a broad question, it's like you can be siloed into thinking you're right when you're actually not.
That's right.
That's a really good way to put it. Like I knew how it worked, but that analogy it really helps out. So, and
maybe we should add a third thing. A lot of times people are using data and it's not a good representation of what they're trying to depict.
Okay.
And so just think of it like in that example, or we do it all the time. I mean, we did it on our last episode with Sherry Traxler, which by the way, she was fantastic. We got to have her back.
For sure.
But weight is what we use to determine if we're healthy. We're missing. You know what I mean?
So it's over attributing significance to a particular variable.
Yeah, but the truth is, weight by itself, by the way, means absolutely nothing. Weight plus height is a little bit better. But again, it doesn't take into consideration muscle mass or things like I'm overweight, according.
Same. Oh, I am. Sure.
So I think what we're saying there is sometimes data, it was captured correctly.
Yeah.
It wasn't wrong. It's 160, 208, whatever. The numbers are not wrong, but it is not a representation. This goes into reliability versus validity. And things like that. Are you actually measuring what you actually need? And we're going off way too much. Let's go back to data. I do want to talk about data in a very simple way.
Okay.
We talk about it in most cases when we're doing data science. And so when we say data science, the most things we're going to talk about today, you could think of the data probably would look good in a spreadsheet. Okay?
Yep.
Which means it has columns. Those columns probably represent a feature of the data. Like your height, your weight, your heart rate. Those are columns of data. But then for every observation, patient, person, whatever you want to say, that's a row of data.
So it's two-dimensional so far.
And that's usually what we think about. So it's structured data.
We talked about this when you were explaining what a database was too.
Yep.
So go back and listen to that episode for the more detail. But in this case, you got a two-dimensional view, which is what we're all used to.
Right. Yeah, and so what we're trying to do is take those observations and features, and in most cases in data science, we're looking at those features and seeing which ones relate to others in a lot of cases.
Right. So the way that I've done that traditionally, just through Excel, is pivot tables.
Sure.
So I use a pivot table to compare one variable, like one column thing, to a row.
That's right.
And then you can include more than just one, and that's what helps a lot in that situation. But in data science, like I imagine that the scope of what you're trying to do is much, much larger.
So the pivot table is the analyst role.
Yeah.
Probably.
Yeah.
When you want to make it a mathematical problem, it becomes the data scientist role. And now you're getting into things like regression and classification modeling and doing things there.
So real quick, you've mentioned regression a lot. What's the super high level term for, or what's the definition of regression at a high level?
And so regression is basically looking at certain things you know about data, independent variables, usually what we call them,
Okay.
and seeing if it has a relationship to another variable. So if I say variable, I'm gonna make it very simple. Let's go use an example today. Predicting the price of a home.
Okay.
Okay, that is a prediction, or you're going to sell a house, and you want to know how much to put it up for sale for. You could just with pivot tables look at different house values and square footage and say, oh, looks like everything's $250 a square foot.
Yeah.
And you multiply the number of square feet of your house, and you get a price. Technically, that's kind of regression. And so it's simple regression. You took one variable, square footage, and you found the algorithm, which meant the slope of the line. And we remember y equals mx plus b back in the day. That is, what? All right, and Jeremy, I'm not really meaning this, but Jeremy, cut. We're not doing this anymore. He doesn't remember y equals mx plus b. I cannot do this podcast.
I've not done math in a long time.
I'm literally talking like 6th grade when you looked at the slope of a line. When that is literally regression.
I had pretty poor teachers.
I'm not going to go into how I feel because I'm going to sound terrible about Mississippi and things like that. But
I mean. Yeah. There were a lot of things that I've learned as an adult about like graphing and things that would have helped if I knew actually when I was doing it. Like the relationship of sine, cosine, and tangent to the real world. It blew my mind when I was like, there's a practical reason to know those 3 things.
Oh, wow. Absolutely. Well, I'm going to keep us down the regression. So if you're looking at one variable, comparing it to another one, that means you're looking for a correlation.
Yeah.
And again, we're looking at regression. So you find out a slope, you find out your y-intercept, and you create a model based on that. And then you multiply basically by whatever your independent variable is in that case, which in this case would be square footage of a home, and it gives you the price. But you know, and I know that there's more that goes into the price of a home than just the square footage.
Yeah.
So what else would be part of that?
Like the acreage that it sits on, the recency around remodels, like how many bathrooms it has, like because
well, just in general, bathrooms, number of bathrooms.
Yeah, square footage is not equal throughout a house. Like
that's right.
The kitchen is higher value, the bathrooms are higher value, porches are higher value. Like some amenities help out a lot, like garages and things like that. But then some amenities take away, like pools, and so there's a lot of things that go into it. And so I see where you're going with this.
Yeah, and so the best model would probably include all of those factors. So you can look at square footage, acreage of the lot, number of bedrooms, number of bathrooms, car garage, 3-car garage, or not and so you can start getting into that. Of course, we know location matters. So we have to have a way to equate for location, which is hard in data. And so you add all those factors up. Those are your independent variables that are helping you to create the dependent variable. So dependent means dependent on independent variables.
That's like we were talking about in the independent and dependent betting things, or the parlays. It's like an independent instance stands alone. A dependent instance is connected to something else.
Yeah, and so in this case, independent means there's things that I can probably change. Like, hey, Charlie, you did a remodel. Let's say you added a bathroom. Well, that one extra bathroom now is worth more money. But you can't just say, well, I want more money, therefore I get more money. You have to do something. And it's going to be an independent variable that changes the price of the home.
Yeah, to go back to the Airbnb episode that we did, it's like, do I leave the bottle of wine out on the table or out on the counter with the wine glasses?
Characteristics, amenities, I mean, all the same things we did in the Airbnb. We're just looking to do that here. So I'm gonna bring us back a little bit, and then we're going to go back into regression because it is a big part of what is this big subset of artificial intelligence, but is machine learning. And so a big part of machine learning is regression.
And so you want to jump into machine learning at this point?
Not yet, because I talked about structured data, and I just want to give us the appreciation for unstructured data.
Okay.
Unstructured data means anything that doesn't live in columns and rows. Plain and simple.
How would it exist otherwise?
There's a lot of data out. First of all, text. Text is a great example.
Oh, yeah.
That is unstructured. Audio recordings, video recordings, that anything you glean from that is going to be unstructured.
So everything that's not numbers is potentially unstructured.
And structured, because numbers technically can be unstructured. But the minute I put it into that schema of that two-dimensional columns and rows, that's when it's structured.
But can you, and this is me legitimately asking a question, can you analyze unstructured numerical data?
Absolutely. But it's different techniques. It could be patterns. For example, you could literally, like your watch, technically.
Okay.
That data could be just exported, and it's just one stream of numbers, individual numbers, but it doesn't line up in specific columns or rows. You could maybe clean it and figure out a way, but it might just be the fact that if it goes up a little, down a little, and you could look at the interactions between each of those numbers. Similarly, with when we say natural language processing, it's basically the data science part of text. Okay, so natural language processing. We're looking at text to be able to either predict something about it, in other words, what should be the next thing said, hence ChatGPT, or maybe you're just looking for the most common words that are said throughout something, or how many times, or does that sentence look like it's a mean sentence or a happy sentence, which is sentiment analysis. All of those things are ways to look at unstructured data because it doesn't live in a column and row.
Yeah.
It's almost the interaction between the first word or characters versus the next group.
So you made some stuff click for me.
Okay.
Because I knew that GPT took words and assigned a numerical value. But I didn't realize that what you just described is how it's unstructured data, and that it understands the relationships between these numbers and these other numbers in a mathematical way that I personally cannot understand.
Yeah.
But I get how the analyzing works now.
Yeah.
So that's cool.
Yeah, and I'm not going to go deep into this, but again, I want to talk about machine learning, but as part of that is this thing called natural language processing. And if you think about that, you're looking at the interaction between words is really important.
Yeah.
In terms of a sentence or two words next to each other or an entire thesis, all of that matters. For example, the word bad. Just the word bad, is that negative or positive?
I would assume negative.
Okay, but what if the word not is in front of it?
Then it's not bad.
Or what about if there's other words in front of that makes it,
Yeah.
So you know what I mean? It's, so there's context. So you get into different approaches. There's like, we have different words for it, like, well, technically words, but bag of words. Bag of words just looks at how many times is a word said in a paragraph.
Yeah.
And that's it. And just, the most common, that creates word clouds. You've seen those. Well, now you get into what you get with like ChatGPT. It's more of a vectorization, and that's why they have to assign numbers to words and things like that. And then that looks at the interaction between those words, and then that has meaning. And that's really what you're doing when you're looking at unstructured data in most cases.
Okay, so you're establishing you're using. Do you use regression in these instances to help with that, or are there other methods that work better?
These days, you're using a form of supervised learning. So let's go into. We're going to go top down, and then we'll go into what is regression, what is classification, cluster analysis, and things like that. So to start with, I want you to think about if I had this big circle, and that circle is artificial intelligence.
Okay.
What that means is artificial intelligence is anything that we use a machine for that used to be a human activity.
Okay.
Is that safe to say? I'm making it as basic as you possibly can.
So at work, we do help desk stuff, and so when people call into the help desk, they get options, 1, 2, 3, and then a call tree, or then the machine decides like they hit this button, so I'm going to route them here.
Okay.
And then they're going to sit here until this thing happens, and then they move into an agent's pool, and basically that's when the phone rings. And then once the call is over, this is what it does. And so that that is an algorithm essentially.
Yep.
But it's a visual algorithm that we're building with like nodes rather than like programming.
I'm glad you went there, because everybody hears artificial intelligence and thinks it's this ubiquitous neural network and hard data science, and it is. But it's also the if-then statement that you just said.
Okay.
If I know that there's 3 different options when I call in and I click one of those, it routes me to a specific thing. Didn't that replace a human?
It did, yeah.
There used to be a person that would answer the phone.
Absolutely. They called them operators.
Therefore, that's part of the big, in that, we're not talking the data science part that much at this point, right?
Yeah.
We're talking about just artificial intelligence as a big circle.
Sure.
Is all of those. So anything that's if-then statements, rules-based, or if it's based on this thing called machine learning.
Okay. And so machine learning is in the AI umbrella.
It's definitely in the AI umbrella. And if I was to say an actual term for it, what I look at that as is anytime you are taking data and using that to create an algorithm of any sort to be able to come up with a prediction or an insight, that is going to fall into the machine learning realm.
Okay.
The reason I try to qualify that is I was going down the route of saying it as a supervised learning model. Okay. So there are predictions or predictive modeling, and then there's exploratory modeling.
And we have a graph that we'll probably share with this too. Right?
You're welcome to. This is straight from one of my presentations. Where'd that one go? There it is. And I use the words exploratory and predictive as opposed to unsupervised and supervised learning.
Okay.
But exploratory to me means I don't know what my data is going to tell me. So what can you do in your machine learning world to help me out?
Okay.
And so you put it in, and what's the one way to find out things about large scale data is you group it.
Okay.
And so you do what's either called cluster analysis or principal component analysis.
And this is, so just so everybody's aware, when in the past Charlie has said the first thing you do with your data is play with it.
Yep.
And so is this part of playing with your data?
This is playing with your data.
Okay.
And when I start playing with data, I usually will start with what's the middle point, and then what are the different groupings of my data.
Okay.
So again,
give me an example of grouping your data.
Okay, we'll keep with your housing. Okay. The first thing I could do is let's say I have 10,000 sold homes in the past.
Okay.
All right. So, and we'll just use that as the state of Tennessee. We'll stick to that, just the entire state. Somewhere in the last 5 years, a home was sold. We've got that in a data set, and I'm just saying 10,000.
Sure.
What's the average price?
Okay, that's your middle point?
That's your middle point.
Okay.
That's not that insightful.
No.
But what I can do is, why don't I use a little bit of data science and see if I can come up with different clusters within those homes? So there's 10,000, but I want to know the rich homes, the small homes, the starter homes, and see if, just from an exploratory analysis perspective.
Like if old homes are more valuable than newer homes of comparable size.
See, you've even gone to rules-based again.
Oh, okay.
See, I'm just saying, what do you see different groupings within the data from a completely data science perspective? So it's not,
So
it's not me going, it's not me saying, so you do with this thing called cluster analysis, and there's different ways. There's hierarchical clustering. K-means clustering means you want to know if there's 5 different groupings within my data. And when you do that, you get 500 in one, 2,000 in another cluster, 1,500 in another. And then you start looking at it and saying, well, the average price in that one is only 150,000. This one, it's 350. What's the characteristics of those homes? And so it gives you this ability to see differences within your data, and it's 100% driven by just the algorithm as opposed to the rules that you were trying to set.
Okay, and so to compare this to like what I can do as a human, like I could do this.
You can.
It would just take me a lot longer.
That's right, because it literally is going in and saying, do you look similar to this home? Do you look similar to this home? And so what you could do is you could say, let me look at everything that's over $400,000. And we'll just say that's an expensive home, or these days that's nothing.
Yeah, around here it's not.
unbelievable. So you could go in and do that. Or houses over 3,000 square feet. That could be your rule. Well, what the algorithm is doing is it's just looking to see which ones are similar. And then say, you know what, you're most similar to this one, so I'm going to put you in this group.
Okay.
And you're most similar to this other place, and so you go off into a different group.
So I'm with you. So you group things kind of arbitrarily.
Yep.
And then see what
scientifically.
Well, scientifically, yeah. You arbitrarily, scientifically group these things, and then kind of see, like, that's the exploratory thing, is you're seeing what stands out to you, and then does that start your path to the more intentional stuff, like the more predictive models?
Yes, it does. Sometimes I know what I want to do, and I go straight to the predictive stuff.
Okay.
And I'm going to kind of glance over the other stuff, like I mentioned, principal component analysis. I don't think that's for this audience.
Not today, at least.
No, and it's really for a researcher. If you're a researcher, you get into that. But basically, I talked about columns and rows. Cluster analysis combines things based on the row, right? Because observations, number of houses, that's an observation, each one. Where principal component analysis does it for the columns. And so it'll group the 18 different characteristics down to 5 different main categories.
Yeah, so it'll say, like, from a house's perspective, the cluster analysis is like the different houses analyzed together, and then in the what'd you call it,
PCA.
In the PCA, you're like, how many? Like, there's 5 different clusters of square footage, and it's the first one's 1 to 2,000 square feet.
No, that's still no. So I'll and again, it really this is for the research. But think of, let's say you have 10,000 homes, and you have, let's say, 50 different features of the home.
Okay.
Square footage, every amenity you could possibly imagine.
Sure.
All of those things. So 50, 10,000. The cluster analysis looks at the 10,000 homes and clusters them in similarities. So these are the homes that look similar to each other. These that look similar to each other. Principal component analysis looks at the 50 columns and says, which of these 50 columns look the same?
Okay.
So what's nice about that is if you think about wellness, right? We all know when we say wellness, we're talking exercise, nutrition, mental stress, maybe sleep. Well, the data, if we use principal component analysis and we had all of these different data points, might group into those for us.
So you're not looking at individual columns and what exists in those. You're looking at how those columns relate to one another.
That's exactly right.
Okay.
That's well said. That is the exploratory part. The part that you hear most about is predictions.
Yeah.
And predictions is what's known as supervised learning.
Okay.
That's where I'm predicting the price of a home, where I'm taking all these features and I'm trying to predict this one value. And in that case, what you're doing is you are going and you are taking what's happened in the past, right? Because you got to have houses sold. So what's happened in the past to predict a future sale.
Yeah.
And that's, so I'll even break it down as simple as I possibly can. A machine learning predictive model takes an entire data set and puts all of the independent variables, square footage, number of bedrooms, number of bathrooms, into one data set. It's called the X data set.
Okay.
It then takes that one variable from your past history, which is the price that it sold for, and puts it into its own siloed data set, and that's the Y data set. So these are, if you remember statistics, you had Y equals MX plus B. Y is the predictive one, that's the dependent variable. X then is the independent variables. So you have this X data set of all of your features that you think relate to your one thing that you're trying to predict. And it's only one. We're not trying to predict 18 things at the same time. One thing, and it's the price. That's its own. So you take that, you then, in machine learning, train an algorithm, which means you basically create an equation. That's all we're talking about here. That equation basically looks at all of those different independent variables and says, do you have a relationship to the price?
Okay.
If you do, how much? And if I then knew the actual values, in other words, Charlie, you're going to sell your house next week, and we had in our model number of bedrooms, bathrooms, and square footage. And you say, well, I've got 2 bedrooms or 2 bathrooms, 4 bedrooms, and I've got 2,500 square feet. I take those numbers, I put it into that algorithm that I just created, and it gives me a prediction.
Okay.
So I train a model, I then predict with the model.
Yeah.
Does that make sense?
It does. So one of the best examples is our mutual friend Jason Backus works in retail, and he found himself in a data science job. In a similar way to other people. It's just
former student of mine, by the way.
Oh yeah. So I hear.
Yes.
And but he works in retail, and he's on a team that's in charge of predicting upcoming, like basically how busy they're going to be. So they use it for hiring models, they use it for staffing models, and then in the business they've had a back and forth of like, are these things? Do we trust this outcome?
Yep.
And I guess you probably have the same perspective. It's like some of it's been working, and then every now and again it'll fail. But when it fails, like why did it fail? You go in, you fix it, and all that kind of stuff. And they're now leaning heavily into their predictive models because they've got them tuned up so much. Like they got the equation correct, so to speak. Yeah. And that's in the equation, like you said, that's the algorithm.
That's the algorithm. So anytime you hear the word algorithm, again, in the old statistics days, that was the regression equation is all that was. And that means the slope of the line and the y-intercept.
Yeah.
And that's all it is.
And so that's his job, and all of retail kind of like they're turning towards that because they can not only tell you how many people you need there, they can tell you where things sell the most. Like I predict that if you put something at the front of the store, it's going to sell based off of this data. And if you put it in the back of the store, it's going to sell way less because of this same data.
Yeah. Now sales is the Y data point, correct? And then everything else is part of that X data set in that case. And so whether it's placement or time of the day or number of people on the floor or whatever, those are independent variables that you can manipulate to be able to get more sales.
So I'm glad you said that again, because to go back to the Airbnb episode too, if you haven't listened to that, you should. Those are what you're calling features as well.
Features are what in the data science world we usually call the columns of data that's in the X data set.
Okay.
Or it's independent variables, same thing. But,
so I'm just getting like, this is helping me a lot because it's taking things we've talked about and it's solidifying my understanding of it.
Can I go into the term data rumble for a second? Because
sure.
I do think this is important. X data set, Y data set. X data set, the terms in the past were independent variables.
Okay.
Today we call them features.
Okay.
In the dependent variable side, in the Y data set, we used to always call that in the statistics world the dependent variable. So I'm saying independent and dependent, but in the data science world, that's a target variable.
Okay.
So target variable, features, used to be dependent variable and independent variable, and then in the world of math, it's the Y and X data sets.
Okay.
And that's how, so there's a math version, a stat version, a data science version. The data science term is usually features and then target variable.
Okay. That makes a lot of sense because the dependent variable is always on the other side of the equals
that's right.
in the equation. And
that's so the target variable.
It's dependent on the X variables equaling. And so you go through it like when you're building these algorithms and stuff, like you're essentially building like a template of what it should look like, and then you're pulling what it should look like out. And so there's lots of things that don't equal up, though, right?
Absolutely, and because there's randomness in everything,
right? And
so what you do in machine learning, just to finish it off, is what a Jason Backus would be doing there is again if. We'll go back to the homes again. We have 10,000 homes. We don't train the model on the 10,000 homes. Okay? We take most of that and train the model, but we keep a little bit of it separate so we can test to see if we were correct.
Oh, yeah.
So usually it's 70-30, 80-20. So if there's 10,000, let's say we put 8,000 into the training data set, and then we create the model. So we use 8,000 of the 10,000 to create the model. And then the other 2,000, we use to test it and say, hey, did it work? Were we close? We predicted 250,000. It was actually 245. Okay, great. And so as close as we are to the actual real value gives us a score. Score is usually an R value. R squared is another one that's out there. And that score tells you how good you did. So basically, if it's close to 1, you did good. If it's close to 0, you did bad.
And that's confidence rating too, right?
That's all it is. Okay. And it's we call it the coefficient of correlation, but it's the R value, the R score. But it's simple. If it's close to 1, you did good. 1 means a perfect linear relationship.
Right.
0 means absolutely no relationship whatsoever.
Okay.
So so that really that is machine learning. The other part of predictive modeling is I'm talking about predicting a number. In other words, a number that, like a sales or my income or things like that. Most of the time, we don't do that.
What do you mean?
Most of the time, we try to predict a label or a category. We try to predict a yes, no.
Okay.
In most cases.
Like, will something happen or won't it? That's
right. So I have all these independent variables. Will that lead to this? Yes, no. That is most of the time. That is classification modeling.
Okay.
So if I want to know if the house is going to sell in 30 days or less, that's a yes, no answer.
Okay.
If I look at all the variables and I also look at the price that I have, maybe that I put it up for sale for, will it sell in 30 days or less? And so a lot of times, should I give you a loan or should I not give you a loan? Or is a great example. You're trying to predict if they're going to default or not default.
Okay.
It's not about anything else. Now, you do a regression model. So regression, classification. Regression predicts a number. Classification predicts a decision. And usually, I like to think of it as just yes, no.
Okay.
So in terms of getting a loan, you want to predict whether the person's going to pay it back or not.
Yeah.
If they are, now you go to regression. That's a classification model.
Okay.
Based on their debt to income, all the different things about them.
Sure.
The minute that happens, now you're trying to predict how much you should charge them in interest. That's a regression model. Okay. And because I could charge you 3% or 15% if I think you're risky.
Well, so to go back to the retail model, and you have to tell me if this is on point or not. Will I have enough employees to sell and to service all the customers walking through the door? Okay, now I know that, and that's the classification part. Yep. And then the regression part is like how many employees.
That's right. And so if all you care about is did you have enough of people on the floor, that's a classification model. Yes, no. If what you're instead trying to do is only try to predict, should I have 5? Should I have 6? Should I have 4? That's regression at that point. So you can use these interchangeably, honestly, because you can change a numerical value easily to a yes/no answer.
Sure.
And so we do that a lot. And the biggest reason we like classification modeling is, first of all, either you're right or you're wrong. So when you look at accuracy, it literally is, were you correct or not correct?
Okay.
So what I mean by that is, again...
You mean when you're training it?
And training it and testing it. Okay. So let's say I train them out. So I'm going to go to, should I give you a loan? Okay. Because I've got this lending club data set I've used it 100 times. Okay. And I have all of the factors of you from your credit rating, basically. So you have credit rating, but you also have how much money you make, how long you've been at your job, how many credit cards you have, how much balance you have, all of that. I'm looking at that. And then we're looking at those customers that we gave loans to, but not everybody paid it back. So we can train a model to predict whether you will pay back or not pay back. When we do that, that is classification modeling. Okay, so the data point, the target variable, is a yes or a no. The independent variables in that case are all of those credit history features that I have. Okay. And then I'm trying to predict that yes/no type thing. And so there's tons of different versions. There's decision tree modeling, random forest, gradient descent. Let's keep this simple today. If you want to predict a decision, that's classification modeling. So when you hear somebody say, I used a logistic regression to predict a yes or a no, and you're in the room, all you have to do is appreciate they had a bunch of features, and they use that to come up with a yes or a no decision. They trained that model, and they do the same thing that we did before. You take that 8,000, you train a model, you take the 2,000 to test it. And what you do is you say, okay, I predicted that you were going to default.
Okay.
Was I correct? Yes. Okay, that goes in the yes bucket.
Okay.
And you keep doing that for the 2,000, and you see if 1,800 of those I was correct, well, then my accuracy is 90%. So it's 1,800 out of 2,000. That's it. That's all you're doing. You're just trying to see how accurate you were.
Well, so one of the things that is still kind of confusing to me is like, where does the machine come in? Because we're talking about machine learning. Yeah. What machine is doing this? Because it sounds like you're just doing math.
That's all the machine is helping us doing at such a large scale. We used to do this by hand.
So the machine learning in machine learning AI is just the math. It's like a glorified calculator.
Absolutely. Except back in the day when we did it by hand, we had 30 observations and 4 different features.
We had very distinct limitations.
Yeah, and so I could do the math. Yeah. Well, then we got to using Excel. I mean, I used to literally show how to create the regression R-squared value by hand, and how you would take the value minus the residual and blah, blah, blah. And yes, so we are, but what we get to it at some point, here's where the learning comes into it, it takes it to another level. And this is, and so there's interactions between data points. So there's more to it these days than just straight math. Literally, machines now can learn in the algorithm, and as you feed it even more data, it becomes better. And so there's some different nuances to the interactions between all of those features that makes it even a better prediction. And that's where the learning part is at almost like on steroids these days.
So to take a step back, you've got a set of data, 20% of it you're keeping away for training. And so you train it on 80%. And that's the same. So to put this into the same thing that you were just talking about, a person can do this, and a person can find insights, and change what they're looking for, like mid-process.
Sure.
And what you're saying is the machine learning aspect of it can do that at scale and actually be more and maybe not necessarily more intuitive, but it can bring along a lot more intuition because of what it can look at one time.
Yeah, and I use Python to do my data science stuff.
So now we've gotten around to the machine, but it's actually an animal.
Or a reptile, I guess. But
Still
we use pandas to clean it. So we're back to that. And then anaconda is the wrapper around it. Yeah. Everything has an animal name.
Those weren't just made up?
No. Pandas is the best library tool out there. Wes McKinney, who actually I think lives in Nashville, is the one that created it.
That's awesome.
Yeah. No. But what I'm trying to get with Python is we used to try to hard code all of that. And then we get to a point where they created these things called libraries. Yep. And so the one that we use is called scikit-learn. And we just say, go take the hard coding for logistic regression and apply it to my data set.
Okay.
Here's my X data set. Here's my Y. And what you do, here's how you type it. You say, if your X data set is there, you have your Y data set. You say, take those data sets, you put them in parentheses, and you say .fit. And then it goes and does all of that really hard work that we used to have to do by hand.
Okay.
Then we had to do in machines and hard code it. Then we say .predict so we .fit with the training data set. Remember the 8,000?
Yeah.
We .predict with the test data set.
Okay.
And then we say .score to find out what the score was. 3 lines of code, and I create a predictive model.
Nice.
That's it.
And so, but all of that used to be by hand.
All of that had to be, literally you would have to write out this minus this, square it, and then put it into a row, add all of those up, take the absolute value, then you divide it by the square root of n, all of that. So,
okay.
Yeah.
So I have a question then that a buddy of mine asked me because he listens to the podcast, so he'll hear this. But I'm not the data scientist, so I don't think I'm the right person to answer. He said he recently bought a Python, a how-to Python book for beginners, and should he throw it away now that ChatGPT exists? And I told him no, because you're still going to learn a lot of the foundational vocabulary and principles of data science that will enable you to communicate with ChatGPT better. Mm-hmm. But I don't know if that was a good answer, or I gave him the answer that I thought was good. But what would you say if somebody asked you if they should just throw away their Python book?
Throw it away because it gives me job security. Because the truth is, you still need those skills.
Okay.
What you got to realize where ChatGPT can only get you so far. Mm-hmm. So if I go in and say, create me a predictive model based on this data set, and do that, it's not going to be perfect. And by the way, the hard part of data science, do you think it's creating models?
Apparently not.
It is.
If you use the libraries.
If you get an X and you get a Y, it's the exact same 3 lines of code every time.
Okay.
Every time. Getting X, getting Y is really hard.
Okay.
Cleaning data is 98% of a data scientist's job.
I'm glad you said that, because I have told people in our industry before, cleaning it is where you got to start, and a data scientist is going to get you there.
We really should have started with this, and I should have made this point. If you look at my code, again, you're going to see just tremendous amounts of cleaning that's in there.
Well, what do you mean by cleaning data?
So you get data sets, and let's say I've got one for housing.
Yeah.
And I've got it for the middle Tennessee area. So basically we'll just say Tennessee. Mm-hmm. We know that if you live in Davidson County, it's going to be worth more than if you are in Lake County, which is the northwest corner of Tennessee, which is very rural. Mm-hmm. So you want to factor that in. So you then can take that data and you can take the word Davidson, compare it to Lake, and you create dummy variables out of it. And so you basically can recode data to make it machine learning friendly. That's a good way of thinking of it.
Yeah.
You can't have missing values. You cannot have anything that's character-based. Everything has to be numerical and no null values. None. No blanks.
Yeah.
That takes a lot to get there. And you have some really valuable data in the categorical stuff.
Yeah.
So, we all know that intelligence is based on your hair color. So red hair is the lowest and brown hair is the highest. So we want to keep those categories. And therefore, we create a dummy variable called brown hair, and we put a 1 or a 0 there. And the 1 means yes, and the 0 means no.
All right. I'm glad you said that this episode, because last episode
it was 2 to 1, so I would have not. And of course, that's not true. I used to always use actually shirt color as my thing, because I'd never offended anybody that way. And I apologize for offending all of the red-haired people.
Well, there's only 2% of us out there, so it is the minority of hair colors.
I will say this: I feel like I have an extra, a higher percentage of friends that have red hair, and you're obviously one of those. Because I only have 2 friends, and therefore 50% of my friends are red-haired.
Fair enough.
I got another really bad joke in today.
Yeah.
All right. So can I summarize, and then you can ask me questions? I want to go back to the basics of data. Data is not just numbers. It's text. It's video, audio. It's anything that you use to capture reality. Data can be structured or it can be unstructured. In most cases, in data science, where we're using data to create algorithms and statistical models to predict or look for trends, we're usually using structured data that's in columns and rows, which means observations and features in most cases. In doing so, we can do exploratory stuff like cluster analysis or principal component analysis. In other words, group it based on the rows, group it based on the columns. We can also then go to the predictive modeling side, which is the supervised learning in machine learning. And we're either trying to predict a number, like the price of a home, or a decision, whether we should give them a loan or not give them a loan.
Yeah.
And that's regression and then classification modeling. And we train on some of the data, usually about 80 to 70%.
Yeah.
Depends on your preference, or depends on the size of your data too. That matters as well. And then you hold some of it to the side to be able to see how well you trained that model. And there's a lot of nuances. We could get into all these other things, but that right there is the basis. Now, to take the next, I think we do have to talk about large language models and really what that really is, because that really goes into more of the unstructured data, which is natural language processing. Okay. So when you think of, and we're skipping over a lot of stuff. I haven't talked about reinforcement learning. Haven't talked about the nuances of what is class. But that wasn't for today. Gosh,
today is
so
called
much.
It's Data Science 101 for a reason.
101. And so when we go into, but I do think it's important because we're hearing LLMs like crazy.
Yeah.
What is an LLM?
Like what's an example of LLM?
What is it? If I was to give a definition, what would you think that is? And what I'm trying to get to is not, Charlie, you better know it. What are you hearing when you hear LLM or large language models or GPT-4 out there in the real world?
Well, it's deriving context from conversation or from text, and that's to me, it's like it's almost like magic. And and now that I know, it's like we were talking about earlier, how you use what do you call it, vectors to assign a significance to a word, but then you reinforce that significance based off of its frequency of use and things like that. And that's how some of these language models have been able to teach themselves other languages, because it just applied the same principles from one language to the next, and it finds those patterns. It finds the context. And it's weird because we use inflection to get a lot of that across, inflection and mannerisms.
That's
and
true,
and stuff. But it can tell everything just from the string of words, and so it turns your sentences into, or it turns your words into independent variables, and then measures every word in a sentence, a paragraph, a body of words in a way that gives it context and makes them dependent on one another. And then they train it up so well that it can do that naturally. And so I can naturally speak to it in the ways that I want to. I don't have to use, like if you put stuff into Google and you don't do it exactly the right way, it's like, well, I don't got anything for you.
Yep.
But one of the things that I've enjoyed about ChatGPT is I can just ask it in my dumb ways, like my dumb questions. And it's like, no, I 100% understand what you're saying, and here's the answer.
Yeah, because there's a lot of other people like you out there, but that are dumb. But a lot of people asking it certain ways and they've got that data set. And so natural language processing, this really ties back to the exploratory versus the predictive. Okay, the reason this has become so powerful is really in the past we were only able to do exploratory stuff with text.
Okay. We were only able to do exploratory stuff with text or with numbers? Text. Okay.
So with words on a page, we didn't have a way to know a lot. Well, of course we have. I'm talking about very rudimentary type stuff in this way. Because by the way, most chatbots in the past were if-then statements. They weren't based on large language models.
Okay.
It was if you said invoice, it brought up the FAQ for invoicing.
Yeah.
That's it. And so what we would say is we would, do word clouds. We would do this thing called topic modeling, where it would take all of your data and put it into different categories and say, does this comment look like it belongs with these other comments? Sounds like cluster analysis, right?
Yeah.
The sentiment analysis, same thing. It would kind of say, well, is this good or is it bad? And started blurring into predictive, but large language models are now, not only is it taking this huge amount of text and trying to just look at that, but it's training itself at the same time, because every time you give it a prompt and you give it another prompt, it's helping to know if that was the right answer or not.
So when I go in and I click the thumbs up when GPT gives me
it
a good
loves it
answer,
when you do that.
it's that I'm training it.
You're training it.
Okay.
Yep. And so if you believe in the cause, hit the thumbs up.
Yeah.
If you start asking more questions, or that, I'll literally say, get more defined. In other words, so it's now learned that was not defined enough in that case. So it's based on every interaction that you have is now creating a better predictive model.
Well, okay, so I think there's something important here to point out. So I'm giving it a thumbs up, or I'm giving it approval, or rejection.
Correct.
Based off of my feedback of its answer. But when you're dealing with a predictive model, or like with a language model, like you don't feed its answers back into itself to train it, right?
It's a lot more complicated than that, of course.
Okay.
But what it basically does is it uses what's called transformer model approach, which is it runs through iterations of checks. And the checks are more ubiquitous than that. It's not like, was it yes, no type stuff. So those checks, though, are basically, you ask it, what is the definition of data science? And it gives you an answer. Well, it's trying to check that with other parts of its data, because it'll find other aspects. And it tries, of course, bring those together, but then it says, okay, let's see if that looks good at this one. Yeah. And it will do that up to 96 different times. And that was a number I saw in one thing when it was talking about transformers. And I know we talked about this before. And it's looking at those, but it also is using your feedback as one of those loops as well.
Okay. And just my feedback, though.
Yeah, because that's all it has, just for you personally.
Yeah.
But no, there's nobody behind the scenes saying, yep, that answer for Charlie Yielding is exactly what it should have been.
Okay.
Give it a check mark. No, there's too much going on. Okay. But it is cataloging all of it in your interactions with it. And it's also checking it based on other aspects within their data. So yes and no in terms of how it comes up with that. What you don't have is a regression model sitting there and a specific R-squared value for that answer. But it's close.
I think that makes more sense in the context of ChatGPT, because it can't just decide which of these two on its own, which of these two is correct. If it sees two different pieces of information, it'll say, here's the answer that's most likely, but there's also this. And that nuance that it's able to reply with, that you never get from Google, is something that I appreciate.
Oh, it's so good.
Because it reduces the amount of groupthink and things like that you like the traps that we're falling into on social media and the internet in general right now. The answers we're getting back from ChatGPT seem to like not obliterate that, but it opens things up. It's like, hey, this is the most likely the correct answer, but these things also exist.
And I wish we had the ChatGPT approach from day one, which is the data's not perfect coming into this, so I'm just giving you the best answer.
Yeah.
And we didn't have that in data science. We assumed the data scientist was a magician, and the answer was perfect, based on imperfect data, by the way.
Yeah, that's
and so we don't trust the data scientists like we should. When it should be, Charlie, I'm going to basically tell you your house is worth $250,000, but I don't understand. I don't know the nuances of your neighborhood, of the fact that they're building a prison right down the street, which they're not. But there's factors that go into it that are not part of the data. But based on the data that I have, here's my best guess. Now, I would recommend you adjust it accordingly.
Yeah, I think that's not just with data scientists, though. That's
right.
Any kind of self-search type stuff. If you're not intentionally going for every angle you can, like, okay, so I'm looking up if something is or is not, and I've found the first article says it is, and I read it, and I'm like, okay, I'm done.
Yeah.
Without looking at the other side of it, then you can get into a point to where somebody's clearly lying, and it's just you pick who you trust and go from there. But that's, I think, pervasive across society. And so what you're telling me now, though, is that data science isn't necessarily going down that path any longer. It's more, we know we're working with imperfect data, so what we say is not actual fact. It's like most likely to happen, because overconfidence in delivering information like that is something that I've personally seen in business, like a lot. That somebody will come in and they're like, "Hey, I magicked this up, and here's the answer." And it's like, okay, that doesn't match any data that I have on the same topic. So how did you get that?
Yeah.
And then they'll try to go into explaining it, and then there's a lot of I call it vacuum math. It's like, okay, well, these things, we came to this conclusion because these variables lined up perfectly, or when lined up perfectly, give us this answer. But that's not reality. Reality is everything's mixed together, and it's a lot more complex and nuanced.
Yeah, and I think which that adds to the power of what you can do with data. Hopefully, in the future, I really hope so. And it really, aren't we starting to see recurring themes? Like going back to data in news. Don't just read the first article, right? Yeah. Don't just look at the first of this. Don't think it's 100% this. Make sure that you open up your mind, and also open up your mind to what is data. It's more than just the numbers. And so predicting the price of your home should also start with talking to experts, that are in the area, that sell homes, that know that house that was at that same price took 90 days to sell.
Yeah.
And you want to sell in 30 days. Or maybe you're okay with 90 days, and so price a little bit higher and then negotiate down. You got to talk to people just as much as look at the data.
Yeah. I mean, appraisers, they have a very nuanced job that you can't look at blanket or data in a blanket kind of way and be an appraiser, because they factor all of those personal things in. Having said that, though, they're still people, therefore also imperfect.
Yeah.
And nobody's like, I distrust somebody more when they speak in absolutes than if they act like they don't know anything. Like, if this is the way it is, I'm like, is it though?
Yeah, I'm going to a company next week, and doing a big presentation. I've been working on it for a while. The whole reason is because they're people that need data, try to get it from their analysts. Their analysts do their best, but they're in a siloed approach over there, where they go and they bring it to them. The person that needed the data says, "That's not right," and throws it away, and they're tired of that.
Yeah.
And I'm like, well, you need to start working together and just understand that you're exactly right. It's not exact. It's not the exact number of income or whatever of your client, but it's the best you have based on the imperfect data that you have. And so use that as a tool to empower you to better decisions. And so it's about changing their mindset more than giving them data skills.
So is that a data scientist then?
That person, which person?
The person, the what you just described, that's a data scientist. Somebody that knows the data, but also can communicate with the business side.
Oh, the communication part is so vital. And I think it's definitely that person. Is that a data scientist, or is that somebody that has good data science skills?
Yeah.
I don't know.
So if I'm a business leader and I create a data science team, and I've seen this at a corporation here in town, and then I put them off in this room, and I'd say, here's exactly what you get to work with. Now tell me things. And that's not that did not produce good results.
That is how we started data science teams 5 years ago.
Yeah.
And especially in this area with healthcare. And we're seeing those teams crumble.
Yeah.
And it's not working because there's not the data translator, or more importantly, the data storyteller.
Yeah.
Because if you tell good stories with data, people will appreciate the imperfect part of it.
So the data science, so Jason Baxter, we were talking about earlier, who's this data scientist in retail, his team he works for right now, he loves. One of the very first things they said is go buy some donuts, take them to a location, and hang out with everybody.
Yep. And that's the best advice. There's nothing I do anymore where I don't go to ground zero, whatever it is. If I'm talking about helping people in Nashville in terms of hypertension, I'm going to clinics. I'm going to all different types. And it's changed my life in terms of having better stories. Because if I'm in front of people, a lot of times they're going to believe me. Sometimes I can get some trust out of them, and I'm good at telling stories with data. I don't mean that in like an egotistical way. I'm good.
It's what you do for a living.
I do. It is my thing. And I want them to trust me in the right reasons instead of just, well, that's what the data says, And I've learned so much by going out and talking to people. We've got this new project. I'm actually wearing a shirt right now that says Stay. Mm-hmm. Stay is actually a movement on the mental health, in the mental health space. Yeah. We've got this incredibly big project about how do we work on the mental health of our young youth here in Nashville. Incredibly important work. Man, if all I do is look at the numbers, I'm doing this community a disservice. Mm-hmm. You got to know what it looks like in a high school these days. You got to understand all of those components.
So I think to round out what a data scientist is or are, is you're definitely like, you've got a set of hard skill sets that allow you to play with and explore with and pull insights out of data that lead to action that we've talked about before. But more importantly, you've got the soft skill sets to be able to communicate all the way up and down the business chain, because you pull data from certain parts of it, but then you have to communicate and build trust with, maybe it's the retail store managers. Yeah. And you tell them they need to hire 5 people, but their gut's telling them it's just 2. And so you've got to build the ability to communicate that story to them. But then also on the business side of things, you've got to convince people to spend money.
Absolutely.
And that's the hardest piece in my experience. But in doing so, in having those soft skill sets, you can more effectively use the data that you or use the insights that you come up with to impact and enforce action.
Absolutely. And it doesn't have to be one person. Mm-hmm. So you could be really good at the hard skills.
Okay.
And as long as you're willing to work with the person that can communicate the results.
Okay.
Very well. So, hey, if you're a company of 10, you're not going to hire 5 data scientists. Fair. Unless that's literally the company is that's their role. But if you're a large hospital conglomerate in town, you're going to have teams. Okay. And those teams should round out all of those skills that you just mentioned.
Okay.
And so be the storyteller and have an appreciation for the math and the programming part and really understand the business. But you better understand, the T approach, right? You got to know everything, but you got to know one thing really well. Yeah. If you're on a team, there is the data scientist generalist. And, there's some people, our good friend, Lindsay Clark, that came in for the education episode. She was the only data scientist at her company for a long time. She was the data engineer, the data analyst, the database administrator, and the data scientist. And
she's self-proclaimed hard skill sets, but she's worked really hard on her soft skill sets too.
Absolutely. And she's a lot better today than probably when she graduated with her PhD in communicating the results of data.
Absolutely.
And she really got to know the business. And that's when she got good at it. So, we didn't even talk about what it takes in education to really get there. I know we've had an episode on that, but we could do so much more. We're probably at a good point to wrap it up.
I feel like we've covered enough for me to be able to sit on it and like me personally, at least, like I learned so much that I need to digest a lot of this, because I've drawn a lot of new insights about what it means to be a data scientist and what not just be the data scientist, but work with data scientists too. And so I feel like we've accomplished enough today.
Yeah, today was not about making a data scientist. We want to, but what we want to do is, first of all, just talk about, give you the general appreciation for data science. Then we'd love for you to have data science skills. But really, data science skills is more of the thinking behind it, because it is getting easier. Like you said, your friend thinks he doesn't need to learn programming anymore. You can do a lot of this stuff automated. Trust me.
He was asking. He didn't know.
No, but there are automated tools out there that do this really well if you have a good data set. Yeah. That's the part that you need, in my opinion. Right now, we're not at the point where that's been taken over yet by machines enough.
Yeah.
And then there are people. And there's going to be more jobs in data science as we get going here. There's going to be more jobs in new areas of data science that hasn't even been thought of yet. 5 years ago, I had no idea what a large language model was. 2 years ago, I barely knew what that was. I knew I had them, but they weren't really like it is today, where it's part of our regular vocabulary.
And that's a good point, because that's the reason that we're doing this, is because we want people to know what's coming, and this is only going to grow and grow and grow and grow until data and data related jobs and skills are ubiquitous.
Yeah. So the data scientist can either explore data, and a lot of the data science techniques are kind of around grouping. But then the big part is the machine learning aspect of supervised learning, where we have a known target, the price of a home. Either we're going to give them a loan or not give them a loan, or they're going to default or not default. And we're trying to predict the next person. And those predictions, that's the big part that we hear. That's the machine learning stuff at the basic level. That's the stuff that I teach all the time. I'm teaching I like to think of that as the basics of data science.
Yeah.
The exploratory, the predictive modeling and regression and classification modeling. And if I can get you through that, I've got you on your way to becoming a data scientist.
Nice. So now I need a nap while all of this absorbs.
A nap? Oh, I thought you said app. I'm like, ooh, what app? No, a nap. Yeah, I understand. It is a lot. It is, I got lucky. Like, I was a stat person. My main education was part of the stats, but I loved the tech side. And I just happened to be doing these two things at the same time. And it was the makings, I think, of a data scientist. We have more formalized training these days. It is hard. It is hard, but the more I learn, the more I realize it's not that hard. And I really mean that. You're either grouping data at the column level or the row level. You're either predicting with a numerical value or a label. And all of the other stuff is not as important. And so I'll get people all the time, do I need to learn the stats or do I need to learn the programming? And I'll say, it depends. And that it depends means we're going to have another episode that talks about that, because obviously where you need the nap and we want to get you off to your nap here. So any last questions?
No, I like I said, I've drawn new insights. Like my knowledge about data and data science is like Swiss cheese. And so I filled in a few of those holes today.
And mine is as well. I just have maybe a few more holes filled in than the average person out there. Fair enough. It is, the more I learn, the more I realize I need to keep learning. And I do agree with you. And I just can't thank everybody enough for allowing two people like this to talk about data. And literally for the hour or so that we just talked, I got to talk data science at the basic level. Hopefully it gives you an appreciation. If you think so, again, you can reach us all at dataforall.io, and you'll see all of our episodes. We are at, what is this, number 22, I think.
22, yep.
So that means 44 weeks. We're getting close to that 1 year. And also, obviously, you can find us on Spotify, Apple Music, Google, you name it. And please go ahead and hit that subscribe button. And otherwise, Charlie, anything else?
That's it.
All right, that's it. He's actually looking at me like he's gonna take the nap. So
no, I'm for real about to doze off.
For that, thank you all. I'm Charlie Apigian.
And I'm Charlie Yielding.
And until next time.